Have you ever pondered over the law of relativity and what it actually means? Questioned if it can be avoided? Delving deep into the realm of physics, we find ourselves face to face with the enigma that is the law of relativity. It's an idea that has not just revolutionized our understanding of the universe, but also challenged our very perception of reality. At the heart of this enigma is a man named Albert Einstein. An imaginative thinker, Einstein dared to question the established norms of his time. He formulated the law of relativity in the early 20th century, forever changing the landscape of physics as we knew it. Relativity, in its simplest form, is a theory about space and time. It suggests that these two entities are not separate, as was previously believed, but are intertwined in a four-dimensional space-time continuum. It's a bit like a fabric onto which the universe is stitched, and it's this fabric that determines how objects move and interact. But the law of relativity is not just about space and time. It also introduces the concept of mass-energy equivalence, encapsulated in the famous equation E equals mc squared. This equation tells us that mass and energy are essentially two sides of the same coin and can be converted into each other. What's more, relativity also explains the phenomenon of gravity. It proposes that gravity is not a force that pulls objects towards each other, as we were taught in school, but is the curvature of space-time caused by mass and energy. Taken together, these ideas form the backbone of modern physics. They have helped us understand everything from the behavior of particles in a particle accelerator to the dynamics of galaxies millions of light years away. So, the law of relativity, in essence, is a radical departure from the classical understanding of physics. It's a theory that has transformed our view of the universe, and it continues to inspire and challenge us, even a century after its inception. Did you know that the law of relativity is actually comprised of two parts? Now, this might seem a bit complicated at first, but trust me, it's as fascinating as it gets. These two parts are known as special relativity and general relativity, and together, they form the bedrock of our understanding of the universe. Let's start with special relativity. This part of the theory, proposed by Albert Einstein in the early 20th century, tells us that laws of physics are the same for all non-accelerating observers. What's mind-boggling here is that it also states that the speed of light within a vacuum is the same no matter the speed at which the observer is traveling. So, if you're standing still or moving at a constant speed, the laws of physics work exactly the same way. Now, you might be wondering, what about things that are accelerating or decelerating? Well, that's where general relativity comes in. This theory, also proposed by Einstein but a decade later, takes into account acceleration and gravity. It tells us that massive objects cause a distortion in space-time, which is felt as gravity. This means that the path a moving object takes will be curved if there is a large mass nearby. So in essence, general relativity gives us a way to understand gravity not just as a force, but as a curvature of space-time itself. The beauty of relativity is in the way these two parts interact. While special relativity deals with objects moving at constant speed, general relativity tackles those that are accelerating. They are two sides of the same theoretical coin, each explaining different aspects of how objects move and how mass and energy interact. So, to sum it up, special relativity deals with the same laws of physics for non-accelerating observers and the constant speed of light, while general relativity tackles accelerating objects, bringing gravity into the picture. Together, they paint a comprehensive picture of our universe, from the tiniest particles to the largest galaxies, and everything in between. Now, the intriguing question that arises is, can we avoid relativity? Let's dive into this thought-provoking query. The law of relativity, as we've discussed, is a fundamental concept in physics that describes the workings of our universe. It's not just a theory confined to the realm of scientific research or space travel. In fact, it's intricately woven into the fabric of our everyday lives. Take, for instance, the Global Positioning System, more commonly known as GPS. It's a tool that many of us rely on daily to navigate our way around town, plan long road trips, or even locate our lost smartphones. But did you know that the accuracy of GPS is rooted in the principles of relativity? GPS satellites orbiting Earth are moving at high speeds, and are further away from the planet's mass, which, according to relativity, means their clocks tick a tad slower compared to those on Earth. To maintain precision, the system has to constantly correct for this time dilation effect, a direct consequence of relativity. Now, let's venture beyond our planet. Astronauts aboard the International Space Station experience time slightly differently than we do on Earth, thanks to relativity. As they're moving faster and are in a weaker gravitational field, time for them slows down. This means that astronauts age a smidge slower than the rest of us. We're talking milliseconds here, so don't get any ideas about space being the fountain of youth. Relativity is not just a law that we can sidestep. It's a fundamental part of our universe, deeply ingrained in its structure and behavior. We can't simply decide to turn it off or avoid it. Even if we're not consciously aware of it, we're living in a world governed by relativity every single day. So, as you can see, relativity isn't something that we can simply choose to avoid. Despite its prevalence, there are numerous misconceptions surrounding the law of relativity. One of the most common misconceptions is that the law of relativity only comes into play at high speeds or in the realm of black holes. This couldn't be further from the truth. The law of relativity is always at work, even in our everyday lives. It's just that its effects are so minuscule at our human scale and speed that we don't notice them. Another common misunderstanding is that relativity is all about time dilation and length contraction. While these are indeed fascinating and mind-boggling phenomena that arise from relativity, they are not the whole picture. The law of relativity is fundamentally about how the laws of physics should look the same to all observers, regardless of their state of motion. Some people also believe that relativity is purely theoretical, with no practical applications. This is a major misconception. Without taking into account the effects of relativity, our GPS systems would be off by several kilometers. This is because the clocks on the GPS satellites tick slightly faster than the clocks on Earth, due to the differences in gravitational field and their high speeds. The idea that relativity contradicts Newton's laws of motion is another misconception. In fact, Newton's laws are a special case of the laws of relativity, applicable when speeds are much less than the speed of light. It's like how a square is a special case of a rectangle, but not all rectangles are squares. Lastly, some people think that relativity is beyond human comprehension, that it's only for the Einsteins of the world. This is a misconception that we hope to clear up through our discussions. While relativity can be counterintuitive and complex, it's not beyond our understanding. With time, patience, and a bit of curiosity, anyone can grasp the basics of this beautiful and profound theory. As we've seen, the law of relativity is not just about high speeds or cosmic phenomena, it's integral to our everyday lives. Let's recap what we've learned about the law of relativity. This fascinating concept, first introduced to us by the brilliant mind of Albert Einstein, is truly a cornerstone of our understanding of the universe. It's composed of two parts: special relativity and general relativity. Special relativity, the first part, taught us that space and time are not separate entities, but rather interwoven into a single continuum, known as space-time. It also introduced the idea of the speed of light as an unwavering constant, regardless of the observer's motion. The second part, general relativity, took this a step further. It painted gravity not as a force, but as a curvature of space-time caused by mass and energy. It showed us that the path an object takes is not determined by a mysterious force pulling it, but rather by the shape of space-time around it. Then we delved into the question, can we avoid relativity? The short answer? No. Regardless of where you are or what you're doing, the laws of relativity are at play. Whether you're sitting, walking, or hurtling through space at thousands of miles per hour, you're subject to these laws. They govern the fundamental workings of our universe, from the tiniest particles to the most gargantuan galaxies. We also debunked some common misconceptions about relativity. It's not some abstract, purely theoretical concept. It has real, tangible effects on our everyday lives. For instance, GPS systems we use for navigation work accurately because they account for the time dilation effect predicted by special relativity. In conclusion, the law of relativity is a profound and pervasive principle that shapes our understanding of the universe. It's not just a staple of scientific theory, but an integral part of our daily lives, often in ways we don't even realize. So, the next time you look at your GPS or think about time, remember, you're experiencing the law of relativity in action. Not quite the spiritual law of relativity, but we will cover that in another video. Did you learn something? If you did, like this video and subscribe.